Probably Haskell is a thing for special people, maybe. So I've been doing programming for about 15 years of my life, and 10 of those I've been doing the standard interpretive, imperative, object-oriented languages. Everything like Java, PHP, Python, all those standard things. And then suddenly I got introduced to Haskell and decided to myself that this is the thing that I absolutely must switch to, because it solved most of the questions that I had previously. And well, I'm not telling this just to brag. I'm telling this as trying to point out that, from my opinion, Haskell is by far the best practical language that I know of. So, with that said, today I'm going to be talking about problems of Haskell. But I absolutely recommend doing this. So first things first, the terminology. I suspect there might be people who aren't quite well acquainted with the language. So here is how you can declare types. First example is how you can declare a typical enumeration, which is, well, you kind of get it. The composite single constructor is just an example where you can have an x, y coordinates, and then comes an example of a parametric type, which you can see identified, and then it's followed by this thing A, which is a parameter, which you can use to put in some specific type instead of it, and you'll get a specific type in the end. And the next example actually makes more sense in this regard. The type maybe, please look at it. For the guys coming from Java world or wherever you have nulls and all the related problems, you might find out that this might be the solution for your language. And actually in Java, they are implementing it as type optional. Well, basically what this thing is, consider that you have some input form where a user can input his gender, but he may not. It may be an optional form, so the type of input that we will have will be maybe gender. Either is a more specific case where you can, instead of nothing case, you would have a left with some type which you can assign there. Usually in Haskell we put a string there just to denote a failure, to describe what happened. And that's described here with the failable gender type. And actually those declarations here are type aliases. Well, it's simple. And then comes type classes. This is quite a subject. If you are not familiar with Haskell, I've made kind of a translation into Java. I don't think it translates directly, but it kind of introduces it as a pattern. Here you can see a very basic abstraction from Haskell. Well, not from Haskell, from mathematics, but Haskell, use a lot of mathematics here. And it's a typical Java interface, which declares some type, which is parameterized by some type, which you can have an empty value of whatever you want. So it depends on how you implement it. And you know how to append those two types. This is basically all you know about this type. And it doesn't matter which interface this type itself implements. It's absolutely free. And this is how you, for instance, could implement an instance of this interface for type string. Here you can see that the method empty has an empty string, which is pretty logical, and appending just concatenates to strings. In practice, you can use this to implement polymorphism in an ad hoc way, the way they do in Haskell. For that, you can see in this function that a list comes, again, over some type A. You don't know what this type A can do, absolutely nothing. It may be some data, whatever. But what you do, you do provide an instance of this Manight class, which you can later use inside this function to define some new functionality. In this case, this function traverses throughout this list and concatenates everything inside it. This is how you can use this function on strings. So it's basically just a join, but done in such a way that you didn't require a single function from string. So I think it's kind of cool. And that's the way type classes are implemented in Haskell. Here you can see the Manight. And after this, an instance for string. I'm not sure it is like that in the language itself, but it kind of resembles. And then you have this fold function, and the first difference here is that Manight comes as a constraint on the type A. You don't actually provide the specific instance. The instance is inferred. It is implicit, and the compiler itself finds whatever instance is available for this type whenever it needs to use this class. And the next point of terminology is the records. So the subject of this talk. For the people unacquainted what they are, the simple example will be a poser. Well, again, a point which can have an x and y coordinates. Basically, that's it. Records have no behavior. It's just data, which you can access by a field name. That's everything about them. In Haskell, records are currently implemented as a syntactic extension. You can see the same data declaration as we've had before, but now we assign labels to those two not parameters, but I don't know how would you call them?
Fields?
Yeah, fields. And the way this thing works currently is it basically desugars these syntax, the field names that you have defined. The compiler desugars it into function declarations as we have in the below. So take a look. Well, basically, we have name, and we accept person value, and we just extract the name part from it, and we return it. Considering age, we just return age. Pretty simple. But when it comes to updating records, I have to remind you that Haskell is absolutely immutable, so you don't actually change anything when you're dealing with values. You only provide the new thing. So updating implies that you give a person and you receive a new person back. There is no mutation. But the updates, when applied to records, the way they are implemented is just spatial syntax. And so far, even looking back when we had those functions, it kind of may make an impression that it's so, well, well, quite a clever solution. You have functions everywhere. But in practice, it has turned out to be quite a nightmare because, well, yeah, we got to this part. The first problem is, and the most daunting one, everyone in the Haskell community has been crying about this for years. The problem is basically that you can't have two records having the same field name in the single module. And, well, everybody says that Haskell is so smart, and when you see a simple problem like this not being solved, it kind of changes your impression. Yeah, to this day it hasn't been solved, but fortunately we will reapproach this today. The next problem is partiality. Previously, when we've seen data types like either or maybe, today, those types were implemented using what is called constructors. So you have a type A, and it has two constructors, A1 and A2. Each of them has different fields. So A1 has field 1, A2 has field 2. But both of them, the values which you implement using either of those constructors, will have a type A, just A. So that is why it will, whenever you use a function field 1 on a value created using a constructor A2, which does not have field 1, the type checker, the compiler, will let it compile just fine. But during runtime, you will run into an error. The next problem, well, it is kind of related to namespacing problem, is that while you can have two constructors share a field name, but it requires you to make them have the same type. And once you implement it using different types, it won't compile. It's not a big problem because nobody actually does any such thing, but it is a problem though. At least it's not pretty. Constructor redundancy is not actually a problem, but it's more like a statistical problem. When you see that you have to type person twice, what's the purpose? And the last one has been a huge pain as well for a long time. Below you can see a function which tries to, well, not tries, it does, increment a deeply nested field. So we have a value of type person, which has a birthday. We dive into dates, which is the type of birthday, and we try to update one of its fields. And for that, you can see how much times we need to repeat ourselves. That's amazing. And luckily, today, this last problem is already solved, and it's done perfectly. You can see how we can do the same function using lenses. There is this standard function which comes with practically any of the lenses libraries. It is called over. It allows you to use lenses to point to any deeply nested fields that you want to operate on, and as the next parameter, it accepts a function which you want to apply to this particular deeply nested part. And after that, you get the whole structure updated. But lenses require some boilerplate. These function calls, which with title make lenses, are macros, which in Haskell are called template Haskell. It's not much of a boilerplate, but there is. So in the end, lenses do solve a problem, but just one, the last one. We still have all the other 4 remaining. And the solution is anonymous records. Currently, they are implemented as a compiler preprocessor and a library accompanying it, which contains the types behind it. And the last part of this talk will be about anonymous records. So this is how we can approach. Oh, I think not everything fits in, but well, we can deduce it, hopefully. So the first thing is the way we can declare types using records. You can see some new syntax introduced here. Those opening curlies followed by tilde. This is the way you can define a type of an anonymous record which has lazily evaluated fields. And this is another topic here, which I haven't covered before. Haskell is a lazy language, which implies that whenever you refer to anything, or whenever you even pass a function, when you think a result of it, you might think that it is evaluated, but it's not. It's actually delayed and deferred up until the last moment before you output it into the screen or send it to network, whatever you do. Before that, the Haskell just accumulates whatever it needs to do. This implies laziness. However, it might result in some troubles. You might get a stack explosion if you do this improperly. So that's why people often use strict types, which evaluate immediately as soon as you assign values. And for that purpose, this library, the anonymous records, also come in another taste, which uses, instead of tilde, it uses a bang to identify strict records. So here you can see several things. We are defining a type person as an alias. It is not a new type. It is just a name we are giving to an anonymous record. Another thing is that we are free to use anonymous records deep inside of this type declaration, as we do with the birthday field. And the next thing is that we have 2 records having the same fields named name. Country has name and person has name, and there is no problem in that. Despite them being anonymous, we can declare new types, data declarations using anonymous records as well. And there's actually almost no price to pay. I'll talk about the prices later. Oh, yeah, we can declare multi-constructor types. As you can see, again, there are no conflicts in the namespaces, and we can easily use different types for the same fields. No problem in that. And here, yeah, the memory footprint concerns. Well, actually, there are almost none until. Yeah, those 2 types, they occupy exactly the same amount of memory, so we're losing nothing here. Same applies to strict records as well. In the upper part, you can see how you can declare a strict record using the current Haskell syntax. And here is the part that implies some price to pay, which is, the GHC compiler includes a special functionality which allows you to unpack an existing type into the new type that you declare. This allows you to save a little amount of memory because it removes several steps of boxing and unboxing, but it as well comes at a price that you will have to do some boxing during runtime. So this comes at a price of a little performance loss. And unfortunately, it is, at least today, it is impossible to implement anonymous records which could utilize the unpack functionality. So this is the price to pay. Performance is absolutely the same. We don't do anything new. We use all these standard methods of accessing or modifying the data structures. And here is how you can manipulate and access records fields. We introduce the Preprocessor library, which we're talking about today, introduces a special syntax for record field lenses. It uses the @ symbol, and basically we can see the same example as we've had previously with the lenses library, but we don't have any boilerplate code. We just have a type declaration and we are free to use lenses. Declaring values is pretty straightforward. You just declare it. So that's it. We have all our problems solved at the single price, the lost ability to use the unpack pragma. How they work. The library comes with a set of predefined types, which utilize the type literals functionality to identify fields. Those strange looking N1 and 2 colon symbol are types which have a kind symbol, which implies, simply speaking, it means that those parameters must be strings on a type level. And since type level strings are type level values, they are values, and being values, they can't have namespace. Since they don't have namespace, they have no conflicts in namespace. So this is how we solve the namespace conflicts problem. This is what the preprocessor actually does. So having defined a record using the syntax above, you get the preprocessor outputting a code like this, which then gets passed to the standard Haskell compiler, which deals with it perfectly well. One thing to notice here is that the outputted value contains fields in a different order. They are sorted alphabetically, and there is a reason for it, and this is the reason. Due to it, both those values get sorted, and they become identical when they are passed to the Haskell compiler. This absolutely makes sense, because otherwise, what's the purpose in having an ability to refer to fields using their names, but them being dependent on their order? It didn't make sense to me, at least. And this is how the lens functionality is implemented. You can see a type class here, which we've previously talked about. It is a quite simplified version of the type class that is actually used in the library, but kind of gives a perspective. So it defines a single function which accepts a field name parameter and gives out a lens. That's it. The lenses you can later compose and do whatever you want with them. And instances for this type class are defined for every record in the library. I have actually messed up here a little bit. It should be not record, but either lazy records or strict records, since the library is now updated. And this is how the sugaring of the label declarations happens. You can see it refers to this field lens function, which is part of the field class. And we have birthday, and we refer using the field name type birthday. It uses an undefined value because this field name type has no implementation on the value level. It only makes sense for the in our purposes. It only makes sense. It is only required on a type level, so it has no value. Yeah, so use cases. Well, basically, the trait that I've noticed is all the use cases are somehow involve a type which you only need to define in one place and use it in one place. In this case, you can see how easily you can encode records into JSON. They translate quite directly. This thing is cool. Previously, all of Haskell I/O libraries were full of functions which you can only understand after looking at the docs. But here you have a connect function. What is byte string? What is the next byte string? Only looking at the docs will tell you. But now you can use a record which has fields to refer to. And here you go. You have a name function parameters. And here I give a little introduction into another project I'm working on currently. It is a template engine. Actually, this project was the thing that inspired me to, the idea of the record library came from this project. At first, I needed to render some HTML. I needed to use some template engine, and after looking at all the libraries that were on Hackage, I noticed that most of them simply turned off Haskell's type system and used dynamic types. Well, you have language which is regarded to as having one of the most powerful type systems, and you just throw it away. I couldn't stand this. I thought that we need something better. And another problem, there was another problem, it was that you had to compile to render those templates at runtime. You'll be wasting resources. Of course, you could add some caching layer, but you'll still be wasting resources. You could do this at compile time, because I don't think anybody has an example of a server running and you coming in and changing templates. Whenever you change something in your server, you actually recompile it. That's the common approach. So that's why this library targets rendering of templates at compile time. And this comes with compile time checking. All the errors, all the missing values, all the values pointing to missing values, everything gets type checked during compilation. So when working at this library, I found the problem that I needed to refer to fields somehow. And since the older approach, the older records didn't quite provide a nice way to do this, I've been thinking and came up with the records library. And in the end, you get something very simple. Oh, I have a mistake there. Here it should contain $1 before like a. That would imply that this thing is macro, and it expands at compile time. In the end, it produces a text builder value. Text builder value is basically a string which you can easily concatenate without losing too much performance. Well, it is a string value optimized for concatenation. And as a parameter, you can see this function receives a record, and it's easy to define what you need to pass to it. And yes, this record needs to, all the fields of this record need to contain text builders as well, because in the template engine expects everything to be a text builder, but it actually has a point as well. All those modern rendering engines, they come with fancy filters, formatters, or whatever, and it often ends up being some kind of a weird version of PHP. I think the approach should be absolutely different. You have this powerful language, whatever language you read, all its capabilities allow you to input libraries, depend on them, do whatever you want, and produce nice strings that you want to show in the end. So the template engine should do only one thing and do it well. That's the thing we've been talking about for years now, that every component should be doing one thing. That's the best approach, most practical one. And from my opinion, a template engine should only lay out values. And that's the thing that this thing does. It has some more complicated operations, but this talk is not about Leica. Let's finish with this. The missing part in the end is a dependency on the base library, so it doesn't really matter here. This is the way you can use records today. You can write all the code that we've written before. It already is compilable. It is usable. There is one problem though. The preprocessor is in kind of a beta stage right now. All the errors are misplaced. They don't point to correct locations in code. But it's temporary. I'm working on it, and it should be, the later versions should fix it. And the main thing here is the line after GHC options. It basically tells the compiler to use this preprocessor, and it will be used throughout your whole project. If you don't want it to be used throughout your whole project, or you want to just apply it to a single module. Oh, I made another mistake here. I've just stolen this line from a different library. It is called HTF, Haskell Testing Framework. Well, instead of HTFPP, there should be record preprocessor. Then this module will compile. Those are the links. And probably, yeah, that's it. Thank you. So, questions, please? Yes, please.
So one difference seems to be that with the normal Haskell records, if you have a data type that has field labels, and you can apply the field accessors directly to that data type. Whereas if you have an anonymous record, you wrap it in a constructor via a new type or a data type. it seems, at least from what you presented, that you first have to unpack the anonymous record that is contained within before you can apply the lens, or does your preprocessor in some way define a lens for the wrapped data type or new type as well?
So it is a two-part question. First, you want to know whether unpacking is ever done. Is that correct?
No, it's not the unpacking by the pragma. I mean, if you have an anonymous record that you wrap up in a constructor via a new type or a data type declaration.
Well, considering this, I think I understand the question. So it makes the question is whether the unpacking happens when I use a new type or data type.
Can you go back to your slide that has a new type example?
Oh, I've pushed the button too much.
Yeah, you go. That's it.
So here you can see that we use a new type.
Yes.
This thing implies that this whole thing gets erased. In the end, we get just a record.
So he's asking, what will be the syntax to access the name field if it's wrapped in the new type? So like how would I write a function from?
Oh yeah. In this case, you would have to define a spatial lens which unpacks and goes into this constructor.
So that I have to do myself.
Yeah, probably.
Okay.
Are you so lazy?
We do the types in it, and then we don't need to do that.
No, sure. Right? You do the types and then.
Yeah.
No, the question was basically whether you have some additional trickery going on behind the scenes that the name and the time accessors are available directly for.
Okay, good.
For the event type.
I'll remind the question to the video audience that it was whether we need to do something to access the fields of new types or data types, and we do. We do have to define a special lens. So yeah, please.
Referring to this, would this reintroduce the problem that counting overloading if you have a name function with two new types and anonymous records, then we would still have to have overloading to this, right? So this wouldn't even work.
What?
So the question was if you can do unpacking just by using name as in plain records. I'm referring to the question before.
So you want to have some function which would do the unpacking of the constructor automatically?
So which thing are you saying you cannot overload?
Well, I was under the impression that one of the problems is that name can only be used in one record because it becomes a function which then unpacks
Yeah.
the name, right?
Well, yes.
Under the old way.
Under the old way, okay.
Yeah.
And your question was, can we still use the old way with the new records, right?
No, it wasn't.
Whether you have a lens, I mean the new syntax or.
Let me show it.
Let
me show it.
You have a lens automatically that goes from event to the string, and you can with this class. I mean, you can certainly define one, but it's not defined
just a
automatically,
second.
if I understand correctly.
Thank you for clarifying.
Any other questions? Considering this one, I can type something.
Let's say I apply a lens to a type that does not have that field. What error message would I get? Or let's say like the view some field for a type that doesn't have that field.
The question is, what if I refer to an inexistent field?
What will a type error look like?
What would be the error? I don't remember, but this is the part that I haven't spent a lot of time on. There will be some error. I don't think it will be particularly meaningful right now, but later it will be completely meaningful. Any more questions?
Are there any default? Can you have default values?
No. Are there any default values? No, there aren't. But, actually, there is one more syntax that I didn't describe here. It is intended for applicatives. I don't remember whether I have implemented it or not, but I definitely will if it's not implemented already. The point is to have something like name h. This is for advanced Haskellers. Yeah. What? Well, something like this. This makes it easier to use the applicative syntax. That's the purpose. Well, basically, the thing before this weird $sign generates a function of a type which of type string int to person of such a type. Any more questions?
Like in a large program, you might have like a configuration record that has lots of fields, and you may only want to have some of them strict.
Oh.
Like, how do you deal with partially strict fields, and how big can these records be? Because it seems like you have to define like a field 9 for having a
yes.
record of 9 fields.
Yeah, I get the question. Thank you. The question is whether how we deal with fields with records which have a lot of fields, and how we deal with records which can partially have lazy fields and strict fields. Considering the partially strict or lazy, you have to choose. Either it's completely lazy or completely strict. The same way you have to choose when you use tuples, actually. Tuples can be strict, actually.
Yeah, but I can easily write my own tuple type that is strict enough.
Well, yeah. In this case, you can't. Well, at least, yes.
Strict default and lazify the strict fields that you want lazy by adding additional indirections.
And the next thing, considering the arities, currently there's 24 records. It could be as much as you want, but the library itself, the record library, will take very long to compile. That's the only reason it's stopping me from generating more.
What if the user who wants a higher arity provides the higher arity type for you? It's in scope. So say I want like 100 fields, and I provide a lazy record 100 type that's in scope. Would the library incorporate that correctly?
The question is whether it's possible for a user to provide records with higher arities, for instance, like 100 fields. I think no, it's not possible currently, but I think it will be possible to do this in a better way by just letting the user pass a parameter to the records library when it gets compiled. He could probably set the top arity that he's going to be using. Any more questions? Yes, please.
How about you have an implementation of anonymous records? Have you ever thought about doing anonymous variants in a similar way?
Do you imply the sum types? Yes. Like either with higher arities? Yes, I have, and I have thoughts about a special syntax for it. It's not currently in the development, but I'm working on this idea. Yeah. Yes, please.
So regarding the applicative stuff that you just showed, I would like to know whether you just rewrite the applicative, the fmap and the apply, so that it sugar's to something that you wrote underneath, or if getName and getAge will have to return some special...
No, nothing. So the question was whether... David, how do I turn it on? Well, that's about it. The question was whether there is any requirement to do something special when we are dealing with applicatives in those functions which we've seen here previously. I imply get name and get age. No, there is no requirement to do anything. It's the usual syntax.
Okay, so get name will really basically just return a string and not wrap it.
Yes, we don't wrap it, we don't do anything special with it. Yes, please?
Why did you use undefined, not proxy? Like, is there a reason for that, or?
Is there a reason to use undefined instead of proxy? Instead of proxy, do you imply the proxy type which comes with Haskell, with GC?
Actually, like, you just wanted to have a value that does nothing except have that type, right? Which is kind of what, not even necessarily the proxy type, you could just add one empty constructor to your field type, or field name type, whatever it's called.
Sorry?
So like, go back to the slide.
I would love to.
But you had an example.
Andreas, could you help me restore the order? Oh yeah, that's a good idea. Just reset the whole thing. It took time previously. Okay. Yeah, good. Thank you. Can you please remind me the question?
So you had a slide where in order to figure out which field you were getting, you provided an undefined value.
Oh yeah. Let me get back to the slide. It's hard to work in this kind of situation. Oh my God. Damn it, I can see this button which starts the presentation.
Try F5.
F5?
Yeah.
Well, at least I can see start from. Yeah, good. So many slides. Can you remind me the question again?
Oh, the part where you're the type class for lenses.
Yes. Oh, yeah, proxies. Yeah. Should be soon.
This one, yeah.
So the first thing here.
Oh, actually, next one. Sorry, next one.
They are both related. Yeah. So the first question is why do I use this undefined thing here? And this second part of the question, why don't I use the standard type which comes with Haskell base library instead of field name? I could use a proxy. So considering undefined, it simply doesn't make sense to define any value for this field name.
Well, actually, so you could actually just give it field name. Go back one slide. You give it one constructor called field name that has no fields. Then you can pass that in place of.
Well, it would make the code prettier, but it is generated code. It's only intended for a compiler. None of the humans will see it. Yeah, I feel that you kind of dislike this function.
You can probably even use proxy hash or whatever it's called now, which is.
So considering the second part of the question, why I don't use the standard proxy type, is because it was only introduced in JHC 7.8, and we be using this library without it allows us to lower the bound to JHC 7.6. That's the reason. So, other questions? Yes, please?
From perspectives from outside of the Haskell community and even very much beginning. So for me, this looks like some library from C++. In C++, there have been these template libraries like Boost, where a lot of the Boost approaches were adapted into the C++ 11 standard later. So is that, I don't have any insight if this in some years has the potential to actually flow into the official
Thanks for the question. It's a good one. So the question was whether there is any intention for this getting into the actual language. It is not the first release of this library that I'm doing today, and the previous one used other constructs to achieve this functionality. It was much weirder and more ugly, but still it's resulted in some serious talks in higher societies of Haskell, and there were some serious talks about actually getting this merged into the compiler as a compiler extension. I think after I make an official release of this, because I've just posted it in this morning. There was nothing on the internet concerning this, so you have first hands on it. After it, I plan just to finish it, to have all the errors working correctly, and then I'll make an official release, and I expect there will be some reaction from the community, and we'll have other talks. Any other questions? Yes, please.
One more question to the memory footprint, just to clarify. So the anonymous record adds one level of indirection. So the new type with an anonymous record is the same, has the same memory footprint as the data with the usual record.
Thanks for the question. Let me rephrase it. Whether the type declarations which use data or new type, which wrap the existing the anonymous records, whether they introduce any memory footprint. In case when you use the data declaration, it does. You get another level of indirection, and but you don't really need to do this way. You can just use the new type construct. The sole point of which is to drop this level of indirection. This whole thing gets erased at runtime, and you're just accessing the record directly. So there will be no extra indirection. Any other questions? Seems like we're done.
I can use it with type alias as well.
The question is whether it's possible to use a type alias as well. Well, that's the whole point of it. You can use it. The anonymous records are not just some declaration. You can't absolutely ignore the declaring it, as we've done with functions, or I imply named function parameters. We don't declare any type. We just use the one existing. This is why you can use type aliases to just refer to an anonymous record. Yes, please.
What class instances are provided for anonymous records?
By default, the question is what class instances are provided by default. By default, all this show, EQ, odd, data, generic, everything you can get for free. And
so how does show and read, or does read exist? How do they look? I mean, how is the...
What is the code base?
What's going to get printed if I show an anonymous record? Is it going to be printed?
Okay.
Exactly the same?
The question is what's going to be printed when a person uses the show function on an anonymous record. What's going to be currently printed is, for instance, lazy record 3, and you get all those strings after all. But it's possible to re-implement it later. It just requires some time. You're free to make a contribution. You're very welcome. Any other questions? Yeah, let's wrap it up. Thank you.